Hey, what's up? It's your old pal, Mr. Cook. We're going to go ahead and start working on this test review. All right, so first part's going to be doing the definite and indefinite integrals. So let's get started. One thing you want to do is familiarize yourself with the list of memorized integral rules. So it's found on the second page of your notes. The left column is derivatives. We don't really need to know any of that stuff. That's for earlier stuff. That'll be nice when we start doing U subs and all that. U substitutions. Most of these first couple rules, you already know. This is the power rule. Here's the one where if you have a constant, the antiderivative is just going to be x times that constant. If you have nothing, the antiderivative is just a constant value. And then exponential function is pretty easy. Exponential function without an e base, like any base like a 2 to the power of x or whatever, you do the antiderivative of that. It's kind of similar to e to the x. It's just going to be 2 to the x. But then you're going to divide by the natural log of the base, so 2, and then plus c at the end. So, that's a good one to know as well. It's not frequently used, but a good one to know. So this one, let me talk about it for a second. 1 over x. It's more common. I mean, I see it commonly written like that, 1 over x, but like equally common is if it's written like this, x to the negative first. Now, if you see x to any power, you usually think to use the power rule, but this is like the one exception. It even says it right here, not when the exponent power is -1. That's a special case. So in the special case where you have x to the negative first power, the antiderivative is natural log of the absolute value of x. Now, that also is pretty important. Make sure you have the absolute value on there because that's like a domain thing. You make sure that you keep it on there so that you can actually express the area, for all x that are defined within the function. Okay, anyways, so, just make sure you know that one. Then these are the trig rules. There aren't many of them, 6. Just, remember them. If you remember the derivative rules, it's just like the opposite of them. You can compare that if you want. And then out of these inverse trig rules, really the ones that you want to know are like arcsine, arctangent, and arcsecant. Do you see why? Well, with arcsine and arccosine, they're identical. Just as one is the opposite of the other. So technically, if you did the arcsine of some negative, just add a negative out in front of it, it'd be equal to the arccosine. Similar to the arctangent and arccotangent, they're just negatives of each other. So really all you got to do is just know the arcsine, arcsecant, and arctangent, and that should be enough. So yeah, those are the ones. Make sure you memorize them. And if you do that, then this is all pretty easy. So, all right, so let's start there. Memorize those ones. And then, we'll move on to the problems. Okay, so now moving on to the problems. So now that you have all that memorized, it's really easy. Use power rule a lot in these problems and just in general you do. So I think I'll just go through this first page kind of quick. And if you want, you can, reference back with that shortcut list if you need to. Okay, first off, whenever I have a fraction exponent, an exponent, in the denominator, I just move it to the numerator. Because if you just do that simple little trick, things get really easy for you. Because 1 over x to the fourth is the same as saying x to the negative fourth. And then this just becomes power rule at this point. So I'm just going to use power rule for this. So I've got 3 and x to the 2 plus 1 over 2 plus 1 plus x to the negative fourth plus 1 over negative 4 plus 1. And then since I don't have any bounds here, any endpoints for my interval, this is an indefinite integral, so I put plus c on it. What it looks like when it does have endpoints is it has like numbers at the top and the bottom for the integral symbol. That's a definite integral. That's where you'd have a constant value for your answer. Okay, so there you go. There's the integral. You can clean it up a little bit if you want. I don't think that you lose any points if you didn't. But, sometimes it's fun to simplify. And then the 3's here divide out. There you go. There's your integral. Number 2, similarly, just rewrite it first. Integral x to the 2/3 minus x to the negative 4/5, and then dx. All right, so if I use power rule again, I'd get x to the 2/3 plus 1 over 2/3 plus 1, and then minus, and then it'd be x to the negative 4/5 plus 1 over negative 4/5 plus 1, and then plus c because it's an indefinite integral. And you can, make it look a little bit nicer, but you can just leave it like that for the most part, and that'd be fine too. You want to simplify integrals when you have to plug numbers in, or when you have to do a second integral. Same thing with derivatives. If you have to take a derivative and take it again, that's maybe where you want to think about simplifying. But in general, just kind of like leave it like that, and you're all right. Okay, next up, number 3. I'd rewrite that first. 1 to 4, and then 2x to the negative 3rd dx. And then use the power rule here. So then I get 2x to the negative 3 plus 1 over negative 3 plus 1. And then now, since it's a definite integral, I've got to evaluate this. So this is the notation that I use for the fundamental theorem of calculus. So once I take the antiderivative, I'm going to evaluate this by plugging in 4 and plugging in 1 and then subtracting it. Here's how I write that up in notation. I draw a little vertical line next to my antiderivative. Then I put a 1 at the base and a 4 at the top. And what that means is that I'm going to plug in the 4 value for any x that I have in there, and then the 1 value for x, and then I'm going to subtract them. But first, I'd probably simplify because I got to plug stuff in. So negative 3 plus 1 is a negative 2. And 2 over negative 2 is a negative 1. So I'm just going to put a negative out in front there. It makes it a lot easier when I have to plug the stuff in. So I'm going to plug in 4 first. So negative 4 to the negative 2nd. Then I'm going to plug in 1. So negative 1 to the negative 2nd. And then I've got to subtract these two. So then I'd subtract them. And that's the fundamental theorem of calculus and the answer to my definite integral. And you can just leave it like that if you want. You can make it look a little bit nicer, I guess. You could write it as like a negative 1 over 16 and then plus 1, or you could write it as 15/16 or whatever. It doesn't really matter. But if you get to like this point, you got full credit. Okay, next up, number 4. Let's rewrite it. So 4 times x to the negative 1st dx. Then we'd use power rule, right? No, we don't use power rule in this case, right? This is that special case. You have x to the negative 1st. This is just natural log. So this is going to become 4 times the natural log of the absolute value of x and plus c. And that's it. So there's the first 4 problems. Number 5, I tell my kids in class to like, whenever they see a square root or cube root, fourth root, whatever, just to rewrite it as an exponent power. So that's the first thing to do. X squared minus 3x over x to the 1/2 dx. Now, when you have some expression in the numerator and it's just dividing by a single term, just one term, then what happens is that one term divides into, every term that's adding or subtracting in the numerator. So I'm going to rewrite this one more time. Well, a couple more times, but just every time it's going to get a little simpler. So the next way I'm going to write it is x squared over x to the 1/2 minus 3x over x to the 1/2. So all I did was just, distribute it basically, like divide into both parts. And then there's this rule, an exponent rule, that says if I've got an exponent in the numerator and denominator, if they have the same base, then what I do is I can combine that into one exponent and subtract the top number from the bottom number. So it just divides it out evenly. So that's what I would do here. So this becomes, rewrite this one more time. X, this part becomes x to the power of 2 minus 1/2 minus, and then it's going to be 3, and then that's x to the 1st right there. X to the power of 1 minus 1/2. And, you can simplify that a little bit further. 2 minus 1/2 is 3/2. 1 minus 1/2 is 1/2. So now this is a really easy power rule problem. So we use the power rule. All right, so this is going to be equal to, let's see here, x to the 3/2 plus 1 over 3/2 plus 1 minus 3 times, then it's x to the 1/2 plus 1 over 1/2 plus 1. And then again, this is an indefinite integral, so plus c, and we're done. Okay, I'm going to give myself a little bit of space to write on number 6. I'm going to erase that. So number 6, it's a definite integral, so I'm going to end up with like a number at the very end. And there's no real like rule that we have for multiplying stuff, so yet. So what we're going to do is just distribute that t squared and hope for the best. So that's what we're going to do. So if I distribute that t squared in there, t squared times 3t is 3t to the 3rd, and then plus t squared, and then dt. And now I'm just going to use the power rule again. So what I end up with is, let's see here. So that's going to be 3. I'm going to go through this a little bit faster, but because maybe I've memorized the process for using power rule this time. So 3/4 and then t to the 4th plus, and then it's going to be a 3rd t to the 3rd. And then I'm going to evaluate this from 0 to 3. So first I'm going to plug in 3 for my t values. So I get 3/4, 3 to the 4th plus 1/3, 3 to the 3rd. And then I'm going to plug in 0. But when I plug in 0 for my t's, they just go to 0. So basically this is like, say, minus 0, so I'm not even going to include it. That's my answer right there. That's my definite integral. Okay, a couple more for this page, and then we'll be done. Let's do number 7. So these are just simple ones. They're just adding, but it's just practicing that rule that we have for both of those. So the antiderivative of e to the x is e to the x. The antiderivative of 4 to the x is 4 to the x over the natural log of 4. And then plus c because it's an indefinite integral. Antiderivative of sine is negative cosine. This is just one that you have to have memorized. And we might have, like, we probably will have trigonometric functions for antiderivatives. So just, don't be intimidated by them. Know that, it's just going to be some rule that you have to memorize. And it'll be one of these, 6. So just, if you haven't memorized, it's going to be real easy. It's going to be one of those. So just look for those, okay? Like cosine. Antiderivative cosine is sine. So this becomes sine. And then it's a definite integral. So I'm going to plug in pi/4 and pi/2 and, subtract them. So this becomes the sine of pi/2 minus the sine of pi/4. And then you can just leave it like that. There's your answer. Cosecant squared, if you look on the little shortcuts list, that's going to be cotangent, negative cotangent. So this becomes -2 cotangent of x, and then plus c. Cosecant, cotangent, that's another one to memorize. That becomes negative cosecant. So this is equal to -3 cosecant of x plus c. Now, this has a clue in it. Secant tangent is one of the memorized ones, but that secant is actually being multiplied in both these. So what you do is just, multiply them in there. So if we multiply them in, we get integral secant of x, tangent of x, minus, and then secant times secant is secant squared of x. And then just, do each individual one. So the antiderivative of secant tangent is just secant, so secant of x. And then the antiderivative of secant squared is tangent, so minus the tangent of x. And then plus the constant. Okay, 2 more. This one is tangent, arctangent. So if you look at arctangent over here, remember you only have to know arcsecant, arctangent, and arcsine, arctangent, and arcsecant. This one's going to be the arctangent. And it's just going to be 5 times the arctangent. So 5 and then arctangent of x and then plus c. And then this one is arcsine. So it's going to be equal to 7 times the arcsine of x and then plus the constant c. Okay, that's it for first page of the review. Now I guess on to the second page through number 18. Okay, see you on the next video. Bye-bye.